All right, everybody. On Thursday and Friday, we're going to go over simplifying radicals, square roots, and cubic roots with just numbers under the radical, and then numbers and variables. So how do we simplify a radical? We're not using a calculator here. We're not going to put in square root of 28 in the calculator. Well, what we think about are our factor trees. So when you go back and you think about factor trees when you were younger, you were given like create a factor tree for 18. A prime factor tree. So you would break down 18 into the numbers that you multiply together to get 18, and you would keep breaking those numbers down until everything was broken down into a prime number, which is just, it has two factors, one in itself. Okay? So then you circle all your prime factors, and there's your factor tree with prime factors circled for 18. This is kind of the same way. So let's focus on the square root of 28. And before we do that though, another good thing to remember, sorry, are your perfect squares. It's a really good thing to have these written down so you can just visually glance up at them, and hopefully you have them memorized. It's really good to have them memorized. So there you go. There's your perfect squares all the way through 12 times 12, which is 144. All right, so let's break down the square root of 28. Well, the square root of 28 is actually the factors 7 times 4. And 4 is broken down into 2 times 2. So I circle all the prime factors, and I recognize that I have a pair of 2's. That means they get to come outside of the radical. They get to leave the party. Only one of them leaves, okay? And it gets placed on the outside of the radical, and the 7, since it's prime, and there's no other 7 to pair it up with, it has to stay under the radical. So the final answer is 2 radical 7. But if you think of it this way, 7 times 4, well, 4 is a perfect square. So we're wanting the square root of 4, which is just your 2. So that's why the plain old 2 gets to come out. So the final answer, when we simplify radical 28, is 2 radical 7. Now let's look at 54. We break down 54 to be 9 times 6. Well, right away, I recognize 9 is a perfect square. So it's going to get to come out, the square root of 9 is 3. So that means an extra 3 gets to come out here and get multiplied to the original 3. And then what's left under the radical is the 6. So 3 times 3, radical 6, becomes 9 radical 6. When I prime factored everything, I noticed that I had a pair of 3's. That's why 1 got to come out and be multiplied there. So let's look at 8 radical 20. 8 times radical 20. Well, if we break down radical 20, it's 4 times 5. 4 is a perfect square. It is 2. The square root of 4 is 2. That's why we bring out a 2 here, and we multiply it to the 8 and get 16. So our final answer becomes 16 radical 5. The 5 stays under the radical symbol. It doesn't have another 5 to be paired up with, and it's prime. So just leave it there. So let me show you a few more examples. So in this one, we have negative 6 times radical 40. Well, I broke down 40 to be 4 times 10. Well, 4 is a perfect square, so that's where the 2 comes from. It gets to come outside of the radical and be multiplied to the negative 6 for a negative 12. Underneath the radical, the 10 stays underneath the radical. So your final answer is negative 12 times radical 10. Okay, let's break down the next one. So we have 2 radical 150. 2 times the square root of 150. Well, 150 breaks down into 2 to a nice perfect square and 6. 25 times 6 gives me 150. So since 25 is a perfect square, and it's 5, the answer is 5, the 5 comes out and gets multiplied to the original 2 for a product of 10. So 10 radical 6 is your final answer. Okay? The next one says 7 plus or minus radical 60. So let's break down radical 60. It's the square root of 4 times the square root of 15. Well, the square root of 4 is 2. So the first time around, I'm going to add 2 to 7 to get the 9. 9 radical 15 is my final answer for that half. The next time I have to take that 2 and subtract it from 7 to get 5 radical 15. So sometimes you have a plus and minus sign here, and you have to do both with the radical, with whatever you bring outside of the radical symbol. So let's go through the odds on this page, and notice at the top I did write all of my perfect squares out. And I'm trying to break down the number underneath the radical, and when I do that, when I tear it apart, when I factor it, I try to find something that's a perfect square. So I found out that 6 times 16 is 96, square root of 16 is 4, so it becomes 4 radical 16. The next one is square root of 98. Well, that's 2 times 49. 49 is a perfect square, so the 7 gets to come out, and the 2 stays under the radical. 7 radical 2. 72, number 5, the radical or square root of 72 is 36 times 2. 36 is a perfect square, so the 6 gets to come on the outside of the radical symbol. 2 stays underneath the square root symbol for a final answer of 6 radical 2. Number 7 breaks down into, sorry about that, 9 times 5. 9's a perfect square. The 3 comes out. The 5 stays under the radical symbol. Number 9 is a little bigger, but I was focused on my perfect squares, and I was like, come on, one of those has to go into 343. Well, I divided 343 by 49, and it turns out it went into it 7 times. So I knew 7 times 49 was 343, so the square root of 49 became 7, and the other 7 has to stay under the radical. All right, and number 11 is 10 times the square root of 96. Square root of 96 is 16 times 6. 16 is a perfect square, so the 4 comes out, gets multiplied to the original 10 that's out there for a grand total of 40. The other 6 has to stay under the radical. That's how you simplify radicals, square roots, with just numbers underneath them, okay? So I want you guys to do the evens. We'll go over them in class, all right? And then we're gonna start adding in a variable and go over that in class on Friday. So I'll add another quick video to explain that. And then you've got some practice to do, okay? So that you're pretty good with this. We've also got to touch on finding the cubic root of numbers. And that is if the number under the radical is a perfect cube, like 2 times 2 times 2, the cubic root of 8 is 2. Because we had not a pair, but a triplet, because we're doing cubic roots now, we got to bring out one of the 2's, okay? Like the cubic root of 125, is that 25 times 5? Let me think of another one. I have to think of another one. But we'll get to that, okay? So that's where we're headed.